how AI is helping in cancer treatment, and this is why it matters. We've all seen AI make funny memes, write emails, and generate seasonal greeting cards. But here's what many people don't realize: AI is actually saving lives. Google's new AI model just did something that should make us all pay attention. It discovered a potential new way to fight cancer. I'll never forget the look on that oncologist's face. I was working with Zakra Scientific, an Indian subsidiary of Singapore's Zakra Group, a premium cancer diagnosis company, presenting our AI-powered NGS next-generation sequencing liquid biopsy blood test to a room full of doctors. We had just shown them how our algorithms trained on thousands of genetic patterns and cancer patient data could predict where a patient's cancer might recur before it actually happened. A common question from doctors would be like, so you're telling me we can see cancer's next move 6 months before it makes it? Exactly. For me, those conversations were as surprising as it was to my audience. But results were evident that it worked. This was about giving doctors a crystal ball, a way to stay one step ahead of one of humanity's deadliest enemies. Artificial intelligence could identify specific genes and areas likely to become problematic, then suggest targeted therapies and immunotherapies tailored to each patient's unique cancer profile. 4 years ago, if someone had told me that in just 3 to 4 years I would hold AI tools of similar strength to what cancer research scientists use and run them on my simple smartphone, I would have called them a fool. Yet here we are. Just 10 or 20 years ago, the kind of AI-powered cancer analysis tools used at the world's top oncology research institutes were only accessible to a handful of scientists at places like Intel's research labs, MD Anderson Cancer Center, or Mayo Clinic. These were million-dollar systems locked away in elite institutions. Today, these tools are literally on our fingertips, on our mobile devices. AI has been democratized. What once required supercomputers and teams of PhDs is now accessible to researchers, clinicians, and data scientists around the world. And that democratization is accelerating biomedical discoveries at a pace we've never seen before. Google's new AI Foundation model just did something extraordinary. It discovered a potential new way to fight cancer. And real scientists in real labs have already confirmed it works. Google teamed up with researchers at Yale University to tackle one of cancer's trickiest problems. Many tumors are basically invisible to our immune system. They hide in plain sight as cold tumors. The AI model, called C2S-Scale27B, which is part of the GEMMA framework, figured out a way to make these hidden tumors visible again by significantly boosting their antigen presentation. The researchers fed the AI information about over 4,000 different drugs and asked it to predict which ones would work to boost the immune system's response in an immune context-positive setting. The AI found several promising candidates, including one drug called Silmitasertib, CX-4945. When scientists tested it in actual cells, the combination of silmitasertib and low-dose interferon produced a synergistic marked amplification of antigen presentation, working exactly as the AI model predicted. This is the same kind of breakthrough thinking I witnessed at Zakra, using AI to analyze thousands of possibilities and find the patterns humans might miss. Look, I get it. AI-generated art is fun. ChatGPT writing your work emails is convenient. But this is what AI is really capable of. Drug discovery acceleration by testing thousands of possibilities in days. Novel hypothesis generation by finding patterns expert scientists might miss. And precision medicine by predicting cancer's next move. We're not talking about making your life slightly easier. We're talking about potentially saving the lives of cancer patients who currently have no good treatment options, or preventing a stage 1 or stage 2 cancer patient from advancing to stage 3 or stage 4, allowing them to spend more time with their loved ones. AI didn't replace the doctors I worked with or the scientists in Google's study. It didn't work alone. AI just gave researchers and clinicians new insights to act on. Real doctors made the treatment decisions. Real people in real labs did the hard work of proving whether those ideas actually worked. This is what the future of medtech looks like: humans and AI working together, each doing what they do best to advance human health. Here's something I want you to understand: everyone starts somewhere. Today, someone might start using AI tools just to write an email or make silly image renders. But those playful experiments open the floodgates. That person gets curious. They realize these aren't just toys, they're powerful tools. After the silly images and email edits come the questions: what else can this do? What real-world problems can I solve? And suddenly, that same person who was making cartoon cats is using machine learning, ML, to analyze medical imaging data or research solutions to real problems. The person making silly pictures today might be the one making life-saving breakthroughs tomorrow. From my days at Zakra Scientific to Google's latest breakthrough, I've seen the same story play out again and again. AI is changing the game in cancer treatment and biomedical research. What was once locked away in the world's most elite research institutions is now available to researchers everywhere. Google's model is freely available on Hugging Face and GitHub. Tools that would have cost millions just a decade ago are now accessible on our phones. The next time someone dismisses AI as just a tool for making cute pictures, remember this story. AI isn't just about convenience. It's about hope. It's about democratizing access to life-saving technology. It's about staying one step ahead of cancer. It's about giving patients and their families more time together. And it all starts by simply exploring what's possible. That's worth talking about. Published October 2025, based on research by Google and Yale University and personal experience in AI-powered cancer diagnostics.